Hello everyone, I'm Hariharan and today I'll be taking you through a very interesting topic blockchain based security, defending the future of digital trust. Now, as we all know, technology is advancing at a lightning pace. With this advancement, unfortunately, cyber threats are also growing every single day. From data breaches to identity theft, ransomware, and even AI driven cyber attacks, we are seeing a huge rise in digital insecurity. So, the big question is how do we create a system that are more secure, more trustworthy, and less dependent on any single authority? And that's where blockchain comes into the picture. Over the next 15 minutes, I will explain not just what blockchain is, but how it works, its security mechanism, the challenges it faces from quantum computing, and finally, what lies ahead for India and the world in building secure digital system. Let's dive in. In this slide, we'll understand blockchain technology and its security implications. First, let's understand blockchain in simple terms. Imagine a notebook where you and your friends keep recording transactions. But here's the twist. Everyone has a copy of the notebook, and whenever you write something in it, all copies get updated instantly. This is what blockchain does. It's a distributed and immutable ledger. Distributed means it's not stored in one place but across thousands of computers. Immutable means once you write something, it cannot be erased or altered. This design itself brings security. Why? Because if a hacker tries to change data on one computer, the other thousands of computers will reject it since their copies don't match. Think about banks today. They'll control your transaction records. If the central server is hacked, all accounts can be compromised. Blockchain removes this central authority. It doesn't ask you to trust an organization, it asks you to trust system itself based on math, cryptography and etc. That's beauty of blockchain technology. Now, let's see an example for this. Take the example of IBM Hyperledger. It's an open source blockchain framework designed for businesses. Walmart actually used Hyperledger to track the origin of mangoes in its supply chain, reducing the time needed to trace food contamination from 7 days to just 2 seconds. That's the power of distributed and immutable ledgers. Before entering into blockchain security mechanism, we'll see what is proof of work. Most of us have heard about bitcoins, right? It uses something called proof of work. In simple words, miners solve very difficult mathematical puzzles, and the one who solves it first adds a block to the chain and gets rewarded. But here's the problem, this requires an enormous amount of electricity. In fact, Bitcoin mining alone consumes more electricity than some small countries. Now, researchers have come up with a new idea called proof of quantum work. Instead of using classical computers, they use quantum computers to do the hashing. A major breakthrough was when they demonstrated a distributed quantum blockchain across four quantum computers in North America. What's exciting is that this method can reduce electricity consumption by to 1,000 times compared to normal proof of work. So it's not just secure but also environmentally sustainable. This shows us something important. Blockchain is not a static technology, it keeps evolving, and with the arrival of quantum computing, we are entering a whole new phase. Although still experimental, think about companies like D-Wave and IBM Quantum. They are already building quantum machines that could one day make proof of quantum work a reality. Imagine if Bitcoin mining farms could shift to a quantum system, we would save enormous amount of energy while increasing security. Now let's talk about how blockchain ensures security. There are more mechanisms like this, but we are focusing on main four mechanisms. Hash function. You might have heard of SHA-256. A hash is like a digital fingerprint of data. Even if you change one single character in a document, the hash changes completely. This makes tampering easily detectable. Public private key cryptography. When you make a transaction, you cite it with your private key. Only you have this private key. Others can verify it with your public key, but they cannot forge it. It's like having a pen that only you can write with, but everyone can recognize your handwriting. Consensus mechanism. Blockchain is a mechanism by thousands of participants. How they are agreed with transaction is valid. That's where consensus come in proof of work, proof of stake, and newer versions like proof of authority are all ways to ensure that new agrees on a single version of truth. Smart contracts, these are self executing agreements. For example, imagine travel insurance. If your flight is delayed by more than 2 hours, the smart contract automatically sends compensation to your account. No middleman, no disputes. Together, these four mechanisms make blockchain one of the most secure digital infrastructure available today. In fact, companies like Ethereum and Polygon, which is an Indian startup, are building secure smart contract platforms. Polygon is used globally now because it makes Ethereum transaction cheaper and faster while still being secure through cryptography and consensus. So, why do we need blockchain security in the first place? First, cyber threats are rising. Every day we hear about companies losing millions to data breaches. Identity theft is common, ransomware attacks are crippling hospitals, and financial fraud are striking. Second, traditional security models are failing. They are centralized. Imagine a bank, social media company, or government portal. They all store everything in one server form. Hackers just need to target that one spot. That's what we call a single point of failure. Third, people demand transparency. Today, we don't just want to trust system blindly. We want to verify. Blockchain provide that a transparent, auditable system where every action is recorded permanently. That's why blockchain has become such a crucial technology for cybersecurity. A famous case is Equifax 2017, where the credit reporting agency was hacked and millions of users' records were stolen. That was a centralized security failure. With blockchain, such a breach are much harder because data isn't stored in one vulnerable location. Also think about WazirX, one of the India's largest crypto exchanges. They emphasize blockchain-based transparency because their customer want to see proof of reserves and transactions. They don't just want to trust, they want to verify. Quantum computing threat. Now, here comes the biggest challenge, quantum computing. In December 2024, Google introduced the Willow quantum processor, which performed a calculation in 5 minutes that would take classical supercomputer more than 10 batillion years. Just imagine the speed difference. This is both exciting and scary. Why scary? Because quantum computers can break the very cryptography that blockchain depends on today. Algorithms like SHA-256 and ECDSA, which are currently unbreakable, could be cracked in seconds with powerful enough quantum computers. The creator of Bitcoin warned back in 2010 that quantum computing could one day threaten blockchain. That day is no longer far away. So, if we don't prepare now, the entire blockchain ecosystem could become vulnerable. Real world impact. For instance, Google's Willow processor in 2024 was a landmark, but already governments like the US National Institute of Standards and Technology are working on post quantum cryptography standards because they know existing blockchain can be broken. This is not science fiction anymore, it's a real urgent and challenge. Quantum resistant blockchain. To tackle this, researchers are developing quantum resistant blockchains. They use new type of cryptography like lattice based cryptography, hash based cryptography, multivariate polynomial systems. These are considered safe against quantum attacks. Collectively, this field is known as post quantum cryptography. One practical idea that Bitcoin developers have already suggested is migrating all wallets to quantum resistant wallets through a network wide upgrade, also known as a hard fork. So, in short, just as we upgrade from old insecure protocols like HTTP to HTTPS in the future, we'll upgrade to quantum safe blockchain systems. One real world example is Algorand, a blockchain platform that is actively researching quantum resistant algorithms. Similarly, National Institute of Science and Technology is running a global competitions to standardize post-quantum algorithms so that companies like Bitcoin, Ethereum, and other can adopt them in the near future. Quantum blockchain hardware. Alongside software solutions, researchers are working on quantum blockchain hardware. Imagine a blockchain system that don't just run on classical processor, but on actual quantum machines. This would make them ultra secure, ultra fast, and nearly impossible to hack. This is still in early stage, but it shows how blockchain and quantum can actually work together instead of against each other. For example, companies like IBM Quantum and IonQ are exploring the integration of quantum processor for secure computations. While still in the lab stage, the idea of blockchain hardware that is quantum native is very real and could be the future of cybersecurity infrastructure. Blockchain security in India's digital future. Let's now bring the discussion closer to home India. India is one of the fastest growing digital economies from UPI transaction to other linked services. Everything is going digital, but with digital growth comes digital threats. Blockchain can play a huge role here. In finance, to prevent fraud and ensure transparent payments. In healthcare, to protect sensitive patient records. In supply chain, to track the authenticity of goods. For example, whether your medicine is genuine or counterfeit. In governance, for tamper proof voting system or transparent record keeping of land ownership. If India adopts quantum resistant blockchain now, it can stay ahead of cyber criminals and also become a global leader in secure digital trust. India already has existing blockchain projects. For example, NITI Ayog tested blockchain for pharmaceutical supply chain to prevent counterfeit medicines. The state of Andhra Pradesh implemented blockchain for land record management to prevent tampering. And startups like Polygon from India are already world leaders in blockchain scaling solutions. This shows that India is not just a user but also a creator in blockchain security space. Blockchain as a cybersecurity force. At its core, blockchain is not just about cryptocurrencies, it's about trust in the digital world. By ensuring data integrity, removing intermediaries, and allowing full transparency, blockchain can revolutionize cybersecurity in the coming years. Almost every sector, from banking to education to government, will use blockchain in some form to ensure trust and authenticity. Here's the reality. Companies like Microsoft, Azure, and Amazon Web Services are already offering blockchain as a service. That means businesses don't even have to build blockchain from scratch. They can simply adopt secure, scalable blockchain platforms from cloud providers. In India, Infosys and TCS are also working on enterprise blockchain projects. So, collaboration is not just theoretical, it's already happening and will continue to grow. The road ahead. So, what lies ahead? First, quantum is here. It's no longer a theory. We must adapt now. Second, collaborations is crucial. Developers, regulators, businesses all need to come together to set standard and deploy secure solutions. Third, investments is key. Building a quantum safe blockchain infrastructure will require huge investments, but it will also future proof economies. This is not just a challenge, it's a golden opportunity to build a safe digital future. India has the potential to become a global leader, just like how UPI made India the payments leader. If we embrace blockchain security early and make it quantum resistant, India can shape the future of global cybersecurity. So, to wrap up, blockchain is one of the most transformative technologies of our time. Its strength lies in its security, transparency, and decentralization. But to secure the future, we must address new threats like quantum computing. Quantum resistant cryptography and blockchain hardware will be the game changers. And for countries like India, this is the moment to take the lead in building a secure quantum safe digital ecosystem. The time to act is now because Securing blockchain today means securing digital trust for tomorrow. With blockchain and quantum technologies converging, we are entering an exciting era of cybersecurity. The example we discussed from Walmart and IBM Hyperledger to Polygon and India's land record system show that blockchain is not just theory but real world practice. Thank you once again for listening, and I hope this lecture has given you both insights and inspiration for the future of digital trust. Thank you.